Okay, so I think, let me go ahead and grab the screen, and I'll try and do a little bit more complicated demo of fit model. Somebody was asking about, they had a complicated cross section and they wanted to try and match it. So um, let me just off the top of my head see if I can figure out what I'm going to do is I'm going to come in here with a fuselage, and give me just a second, everybody, to just sort of doctor this up. But let's change one of these to a rounded rectangle and change that radius a little bit there so that we have something intermediate. And let's make it tall and wide and skewed and keystone. So we'll make it some weird shape. And then what I'm going to do next is I'm going to come into CFD mesh. We'll talk about this another time, but we're going to hit mesh and export real quick. And I did that because I'm using this to create a cloud of points. So we'll say this is my point cloud. And right now what I'm going to do is close that and not show there. But what I want to do is, oops, not insert. I want to import the STL file. So there should be an unnamed STL. So this is, I just imported this cloud of points, right? So this could have come from your laser scan or from a legacy model or wherever it came from. But you can see this is that cloud of points from that shape. And in fact, what I want to do to, there's different ways I could go, but what I'm going to try and do for the user is demonstrate how you would use this to match a given cross section. They wanted to match something intermediate here. And so there's a couple of ways. It is connected. We'll come back to that in a moment, but you'll notice under the mesh geom, if you click on this thing, the other tab, there's an option to convert it to a point cloud. So if we do that and we convert to a point cloud, and then if we show only the point cloud, you'll see this is the kind of input you would get from a laser scan, just a bunch of disconnected points. And I'm going to assume that we want to match one section intermediate here. And so just for fun, to give you an idea of what I'm thinking about, we're going to add a stack. We'll shade it right now, but I'm actually going to go to the end of the stack, and we're going to delete the first couple of cross sections, and we'll go to the beginning, and we should be able to cut it down to, okay, we're down to the minimum number. We'll make this one a circle and just open it up a little. So here we have a stack that's just two cross sections, and I want to match it to somewhere down here, somewhere down the body. So we're gonna match the we'll say we're gonna match it at 12. We're gonna try and match whatever this section is here at 12. And so there's a lot going on. The first thing is you've got a point cloud. There's just too many damn points, right? What are you going to do with all of this? So when you come into fit model, which is there under model, what you want to do, and I don't have a lot of time here without getting us off schedule, but the first thing you want to do is use these options to get rid of a lot of these points. So if we look at a strict left view, I'm going to come in here and choose by region, and that means I'm selecting a bunch of these points. You can also choose by region by just holding the shift button. So you do that a few times. If there's any hidden behind, we've got them now. And what we want to do is hide all unselected points. So we did that. Now we can get out of the select region. Now you can see we're not dealing with all those points. Now we're just dealing with the points in that neighborhood. And we're just doing this to simplify our life. And so what we can continue doing is, what we really want is, if we want to match this section right in here, what we really want to do is only, let's select none. So now we're back down to none. What we really want to do is just select the ones very relevant, really near, there we go, very near that cross section that we want. So we want to just pare down so that we're only looking at those points. And then we want to develop our targets just for those. So that's one way to go about it. I'm actually going to show a different way real quick. Let's come in here and let's get rid of our cloud of points. Let me close fit model first. Let's get rid of our cloud of points. And when we brought in this, I know I'm going over, and we'll just start the next one a little bit late. No, it's somebody else's talk, so I won't do that. I'll wrap this up quickly. The other trick, this is a really great trick, is if you have a model like this that you can bring in wherever it comes from as a mesh, what I recommend you do is you use planar slice. And here we're doing x-axis slicing. And let's just create, I think 3 is the minimum. And let's not use auto, but we know we want one at 12. So let's go from 10, 3 of them to 10 to 14. I think if we start slicing, that's going to create 3 slices, one of which is at 12. And the great thing here is that created it as a mesh geom. So first let's, we'll come in here, but we only want to look at it as the slices. And if we do that and we convert it to a point cloud, what we have, okay, that it did both. Let me delete that. So we're going to need to export this. I know this is more steps than it ought to be. So what I do next is I would export this, which is just exporting the shown set. So it's just exporting these slices as an STL. And here, this is just going to be my slice, and I'll accept. And then I'm going to delete that. I'm going to come back in where my import was. I'm going to import that slice back in. And here, now it's only the slice. So now when I convert it to a point cloud and I then I no-show it and I show just that point cloud, now you see I have a beautiful ring of points at exactly that 12 location. And so now when I go to fit model and I want to select my points with a box, now I select just those points and I have exactly the points at the 12 location, which I'm going to associate with my fuselage. I'm going to do free. I'm going to add my target points, and it should go through and add all 298 of these points with their association to the fuselage, and hopefully this won't crash. But I hope that gives you some strategies and some ideas for working with sort of an arbitrary cross-section in the middle of a geometry and how to go about matching that. I'm not sure where it's going wrong, but I'm over my time, so I'll turn it over to Brandon. All right. So I know this is jumping around a little bit, but I figured I'd just use these couple of minutes to keep everybody from having to stay late. If they wanted to, I can fix that problem. When I selected all these points, I'd selected them here, and I went to associate them. Unfortunately, I chose to associate them with the original fuselage geometry, and instead of choosing the stack, which is what I really wanted to match them to. So that's why it was taking a little bit longer than I wanted. And it then ended up, they all perfectly matched because they fit the geometry perfectly. So let me just come in here with a stack and say add the target, and see it's much faster there. Oops, I grabbed one rogue point up there, and you'll see that what it did when you add them, since they're free in UW, is it finds the nearest point on that shape to it. And you know, it may be counterintuitive that the nearest point's here in the middle instead of up here on the front, but that's actually the nearest point in 3D space. But we know we want to match this front circle. So what I'm going to do is I'm going to get rid of all those, and I'm going to come back and reselect all my points. And here I want to fix them in U to U0. So I want to force it to this center ring, and I'm going to add all those targets, and you can see now it's forced. So that's how I would associate these. If I then want to come in and pick my variables, and I'm working with the stack, and I'm on cross-section 0, clearly if it's a circle, then I just want to use the diameter as a way to fit, and that's one variable. And if I do that, I'm just going to say, let's fit it and see how it does. And so given that level of control, which is just the diameter, this is the least squares best fit right here. And I know that's not very impressive, but you know, this is just how the optimization works, right? That's the best it can do. Now, it might be helpful for me to also give it the ability to move this around. And since this is the first cross section, I can't move it in Z and Y at the cross section, so I have to come to the transform. But let's give it freedom to move it in the Y and the Z. And if we fit it again, what we'll see is it moved it a little, and it's a little bit better fit. Our distance metric got a little better. Again, this is not anything to write home about, though, right? This is not impressive because it's not a great fit. So let's say, okay, we know we're going to fit it better. What if we change it to an ellipse? Now, just like with linking, when parameters vanish or things change, it's gonna remove that diameter. So when I change it to an ellipse, the diameter went away, but now I can change both height and width, and now I have an additional degree of freedom to try and fit. So it's going to crunch the numbers and do the best job it can, trying to fit an ellipse to this shape. Again, right now it can't rotate it, but that's the best it can do. And this isn't thrilling by any means. So let's try, we know that a rounded rectangle is going to do better. It's not perfect because this top is still curved. So we're going to change this to a rounded rectangle, and we're going to let it change both the width and the height and the skew and the keystone and the radius. Why not? So we're going to let it change all of these things, and we'll do a fit, and we'll see how it does at matching this. And you'll notice, well, now we're getting somewhere. And in fact, let me increase that. So now we're at least really resembling that shape. We're close. But remember, this was an intermediate cross section. There was a rounded rectangle over here, and it was a circle to the left. And so we've got some blend, and you'll see that, we're not perfect all along here. And so what we really want to match is not fitting it to a rounded rectangle. This is close. It might be close enough. What we really want to do is match it exactly. And the best we can do for that would actually be to convert this to a C-edit. And so the C-edit type is the Bezier curve type. And when we do that, of course, the rounded rectangle is going to get destroyed. So these variables are going to vanish. And we're going to fit the best fit C-edit that we can to this. So when I do that and I convert, you'll see those variables all vanished here. And we've got now a best fit C-edit on this side. And what we're going to do is we can now tweak the X and Y control points in a best fit way. And first off, I know that these are all smooth. These are nice smooth corners. So I'm going to come in here and I'm going to turn on my G1 options to keep these things smooth. And there's a bunch. So let me just, okay, so now we've got a nice smooth shape everywhere. And actually, you know what? I think this is probably too many points. So I don't want to deal with this many. So I'm going to at least come in here. I'm going to delete some of these from the middle. Oh, that was the starting point. So it doesn't really like me to delete it, maybe. So I'm going to delete some from the middle, and that'll probably help. So now we've got kind of 3 in the corners. Let me see if I can delete that one again. Yeah, I don't think I can't delete that because it's the start and the end. But we've got enough of these, and now we just want to choose which ones we want to add. And so we've got the X and the Y points on them, and we don't want to mess with the U points. We'll talk more about that later. But we've got the ability to move a bunch of these points around. And so what we might do, for example, is we might come and say, okay, I want to move this point, which it highlights it for me. This is number 27. So I want to choose X27 and Y27. Right now, again, there's a lot of these, and if I just do an optimization here, notice it tweaked just that part of the geometry to do the best it could. So in this case, coming in here to a variable tree is going to be a more efficient way of doing it, and I'll be quick just to show you how this works. But we're working on X-sec curve 0, and then we're coming in, and here's all these points, right? And look, there's my X and Y, which they're numbered 33 in here, and that's, as you delete points, these don't get renumbered the same way these get renumbered. So that's why the numbers don't match. But I can just come in here and say, you know what, I want to pick some more of these X and Ys. We just know we want a bunch of them, and this is a really fast way to do that. X, Ys, X, Ys, X, Ys. I love my X, Ys, right? Just choose a bunch of these, and we're adding all these to our fit model process, and that's probably enough. And when I hit fit, you'll notice all these just got adjusted. It looks like it did something a little weird there. I'm not super thrilled with that. Let me try and adjust those and fit again to see if that helped. So something's going weird with the optimization process. I'd have to look at what I'm doing in here in terms of this fit. This point in particular is out of whack. So I'm going to grab that one and bring it back in. That didn't make sense. Let's see if it does it again to us. So some of these, so there's some ringing that's going on, but that's all I've got time for here. But it shows you the process of how you should be able to go in and use this kind of a section to match that curvature if you really need to match an arbitrary section that you didn't see otherwise. And from there, I'm going to go ahead and jump into what's scheduled for this hour. So there was a request to do the fit model demo I did earlier, but without taking a slice first. So let me see if I can pull that off. There will be a little bit of a different strategy. So we're going to, like before, we're going to import the STL, and I think this was the thing that we were working with, and I'll just go straight ahead and convert it to a point cloud, and I'm going to delete the mesh. So now we only have the point cloud, and we wanted to match something before. We were using a stack, and as you'll recall, I went in before and I cut it down. I actually, oops, I went too far. Let's make this a 2 circle, and I'm going to add an intermediate one. And for now, let's move this to location at 10, and then the exsec we'll put a delta of 2, and for the next one we'll put a delta of 2. So again, we wanted to match that location at 12, so we know this section is at 12. That's what we want to match, but we're not going to have a super simple way to do it. So let's quickly turn on symmetry and turn this stuff off. I'm just trying to simplify this down a little bit. Okay, so now we've got something that's a little bit simpler. And while we're at it, we can shade it, and we'll look at it in transparent. So that's kind of a nice way to look at things when you're doing fit model. So to start with, what we're going to do is since we really are just trying to match this middle cross section, we're going to start by just trying to select points near it. But you're going to find that you can't actually do that. You can't just match this, because since we don't have points exactly on this line, we have to match some a little in front and a little behind. And if we're going to match it a little in front, a little behind, then that means we also have to do a reasonable job with this section and with this section in front and behind. So we really need to match all of them to do this. So the first thing is when we come into fit model, as I said before, we don't need all these points. So we'll start by just pressing shift and trying to select only points in this area. And I'm doing this multiple times because of the in and out of the plane, which right now is the Y direction. Points that are occluded won't get selected the first time. And so I'm doing this a few times just to give them adequate chance. And so this is sort of my first cut at the points I want to match. And so right now what I actually want to do is just get rid of the unselected points, right? I don't want to deal with those. And so now I'm dealing with many fewer points. Oh, notice over on the other side, we were not occluded. So let's show all again, and let's hide, let's no show our geom. Let's go back to our left view, and let's do this a couple more times just to make sure that we're getting anything that was occluded by the body. Okay, so now we should have all of those points. Come back in here, hide the unselected. So now we've got all the way around, we've got those points, and we can show this back again. And maybe I got too many. Maybe I should have trimmed this last inch. So what we can do now is we can say select none. And what I want to do is come in here, and now I'm going to select sort of this, the ones that are off the end and off the end over here, because I changed my mind. I don't want them. So I'm going to just select them, and now I'm going to hide the selection. And so now all I have is points that are sort of around the barrel section that I'm varying. And I want to associate them with the stack, and I want it to be free. So I'm going to add to target. And, oh, I need to select all, and then add to target. And there's going to be a lot. There's, that was 1,200 points. And since they all have UV coordinates that are free, that creates a heck of a lot of points to try and match. And the next thing that I'm going to do is I'm going to pick which things I'm going to vary. And so here we need to come into the stack. I'm at this 0th cross section. For starters, I'm just going to do it as 3 circles. So we're going to do it as a circle, and a circle. Oh, this one's an ellipse. We'll make it a circle. So here we're just trying to match 3 circles. We'll give it the freedom to change the Y and Z location of the first one, and so that'll be the overall. We'll give it the Y, Z relative location of the second one, and the Y, Z location of the last one. And so using that, I'm going to hit fit, and we'll see how it does. This may take a little bit of time. What I will say, optimization problems in fit model, this is way more points than I would normally use. I would normally never use 1,200 points. It's really excessive. I'm just doing it because it's quicker to select them and add them than it is to try and pare it down. You don't need a super detailed laser scan with a gigabyte of points to do a fit. You really just need a few points in the right locations, and fewer is better in a lot of ways. The way the algorithm scales, it does get more computationally expensive with more points, but what's more important is how well posed your optimization problem is, i.e., does your optimization problem blow up, or is there a very flat optimum where it can't find an answer, or do you have 2 of the variables that can be used to accomplish nearly the same effect? So in any of those situations, you'll have an optimization problem that's poorly formed, and the optimizer will have a really long time. It'll take forever to converge. This one should be well posed, but I suspect I just had way too many target points associated, and it's not going to work. I probably should have done it with many fewer as a starting point. So I'm probably not going to let this continue. But in general, hopefully this is the kind of idea of how you go about something when you're dealing with the middle of a shape, that if you want to match a single section. In general, I wouldn't ever match just a middle cross section like this. If I'm doing something like a body, I'm always going to start with the nose, and I'm going to match the nose, and then I'm going to go to the tail, and I'm going to get the overall length and the tail right. And then I'm going to look for what's the maximum cross-sectional area, and I'm going to match a section to that maximum cross-sectional area, and I'm going to move one little bit at a time. And that kind of one bit at a time process is how you should use fit model, and it's really just a tool to match the way you would do it with the eyeball these squares. If you were just, looking with your eye and moving the slider back and forth, saying, "Oh, that looks about right," fit model is just a way of doing that a little bit more rigorously. So this is probably going to crash here, or I'm going to kill it. But hopefully that helps to answer that question.